The second video of the Carbon, Climate and Agriculture playlist explains the different interactions between all the carbon pools on Earth, also called the carbon cycle. The carbon cycle describes all the carbon exchanges on the planet. These exchanges take place between the four major natural pools of carbon on the planet: the atmosphere, the biosphere, the hydrosphere, and the lithosphere. The atmosphere is the gaseous envelope surrounding the Earth, which we commonly call air. The biosphere is the totality of living organisms, such as plants and animals, for example. The hydrosphere is the whole of the water present on Earth. It can be as well in liquid form, such as oceans, rivers, and groundwater, for example, as in solid form, for example glaciers, snow, but also in gaseous form, the water vapor. The last pool of carbon is the lithosphere, which is the rigid envelope on the surface of the Earth. The lithosphere includes the Earth's crust and part of the upper mantle. These pools are of varying orders of magnitude. The most important is the lithosphere, containing more than 80 million gigametric tons of carbon. The hydrosphere is the second largest reserve, followed by the biosphere, and finally the atmosphere, containing about 700 to 850 gigametric tons of carbon. We will see together all the interactions between these different pools which form the carbon cycle. The first interaction we're going to see together is the interaction between the atmosphere and the hydrosphere. The carbon dioxide in the atmosphere dissolves in water. The interaction between the carbon dioxide and the water molecules form the carbonic acid. This acid can be transformed into bicarbonate and carbonate ions. Dissolved carbon dioxide, carbonic acid, bicarbonate, and carbonate ions exist together in balanced proportions. The interaction between the hydrosphere and the lithosphere starts with the bicarbonate ion that contains carbon, as we just saw. Bicarbonate ions will react with calcium to form calcium carbonate. Calcium carbonate is an insoluble solid that does not dissolve in water. The precipitation of calcium carbonate leads to the formation of shells of crustaceans, mollusks, and planktonic algae. These same shells sediment, which means that they settle to the bottom of the ocean and will be the origin of rocks containing calcium carbonate, such as chalk or limestone, for example. The oceanic plate, which is the part of the crust under the oceans, is loaded with carbonate, which is, if you remember, an ion contained in seawater. This plate can disappear into the mantle at the level of a subduction trench. During this phenomenon, the temperature and pressure increase. These new conditions allow the interaction of carbonate with silica to form silicates and carbon dioxide. The carbon dioxide contained in the mantle is then released in the atmosphere during volcanic eruptions. The biosphere is generating carbon via two main ways: the respiration and the digestion. The respiration consists in absorbing the dioxygen, mostly known as oxygen, a gas contained in the atmosphere which is not made of carbon, and releasing the carbon dioxide in the atmosphere. Gas containing carbon are also created during the fermentation that occurs during the digestion process of animals. This is especially true for the ruminants, for example the cows or sheep, who release methane, a gas containing carbon, via the flatulence. The biosphere can also absorb carbon. Plants can perform a process called photosynthesis. Photosynthesis consists in absorbing carbon from the atmosphere and fixing it in the organic matter or biomass. In other words, plants can use the carbon in the atmosphere to feed themselves and grow. This process is the opposite of the respiration, in the way that during photosynthesis, plants absorb CO2 and release O2. Plants, and especially forests, are described as carbon sinks because every part of the trees, such as branches or roots for example, are made of carbon. These forests are an interesting way to stock the carbon from the atmosphere. After their death, living things decompose in the soil in the absence of oxygen, which is called anaerobic decomposition. From this decomposition comes the fossil fuels, for example charcoal, oil or natural gas. This process leading to their formation is extremely long, several million years. Because of the time needed to create this type of energy generated by fossil fuels, they are qualified as non-renewable energy. Some human activities, such as driving a car, require the combustion of fossil fuels. In addition to the burning of these materials, forests, which are an important carbon reservoirs, are also burnt as part of the deforestation process. These different combustions release a lot of carbon dioxide and methane into the atmosphere. Despite a partial reabsorption of this carbon by the biosphere and the hydrosphere, the amount of carbon in the atmosphere due to human activity is increasing. All the interactions we previously discovered together are represented here. We can also see that the flow speed varies. For example, the flow between the atmosphere and the biosphere is considered as fast, with 60 gigametric tons per year. The slow flows are, for example, 0.1 gigametric ton per year for the CO2 to be released in the atmosphere via the volcano, or 0.1 gigametric ton per year for the creation of fossil carbon, or even 0.3 gigametric ton per year for the creation of limestone via sedimentation.